Hi everyone, I am Professor Raghavendra MJ, Assistant Professor, Department of Mechanical Engineering, SVIT. Today, I will give you, I will explain the static force analysis. So it is introduction of static force analysis. So topics which I am going to cover are there is kinematics of machines and dynamics of machines. That is KOM and DOM. Static force and dynamic force analysis. Static equilibrium of a body. Equilibrium of two force and three force members and equilibrium of two force member with torque. So in this PPT, I am going to cover these topics. So what is meant by kinematics of machine, that is COM, and what is meant by dynamics of machines, that is DOM. In kinematics of machines, it is a study of motion of a component and studying the basic geometry of the mechanisms or the links. And it is not concerned with the forces which causes the motion of a body or a link. Okay, we are studying the motion and as well as geometry of a mechanism. So you are not studying any forces and couples which produce the motion. That is called as kinematics of machines. Come to the dynamics of machines. In case of dynamics of machines, okay, we are going to study the various we are going to do the analysis of various forces and couples acting on the members of a machine, okay, due to external forces. Also analyze the forces and couples due to acceleration of machine members. As we know, whenever the machine operates, whenever it is in working condition, there are various rotating as well as reciprocating parts are there. Due to that, what happens? The forces and couples will produce. Okay, so those we are going to analyze. In addition to that, the forces as well as couples we are going to analyze in case of lines of machines, and we are not going to deal with any of the things like basic geometry study and motion study in case of dynamics of machines. We are going to only going to analyze the various forces and couples which are acting on the various machine uh, parts or a mechanism. This is about dynamics of machines. Okay, now we have two types of analysis. Actually, if you take any machine member, we are doing two types of analysis: static force analysis and dynamic force analysis while designing any machine component or any mechanism. In static force analysis, if the analysis, in this analysis, static forces acting on the machine member and inertia forces are neglected. So in this case of static force analysis, the inertia forces acting on the mechanism or a member are going to neglect. If the inertia forces are neglected, then it is called a static force analysis. Okay, what is into dynamic force analysis? If the inertia forces also taken into account while doing analysis, dynamic force analysis, that is called as a dynamic force analysis. So, in static force analysis, we are completely neglecting inertia forces developed by some of the forces which are acting on the machine member or due to the operation of the machine member. And in case of dynamic force analysis, we are going to consider the inertia forces into account while analyzing any machine member or a mechanism. That is called as a dynamic force analysis. Static equilibrium. Come to the static equilibrium of any continuum or a body. What is by static equilibrium? When the body will be under static equilibrium, body means nothing but a continuum. Okay, take any body. Okay, how can you say that it is in equilibrium, static equilibrium? What are the conditions for that? So now there are two conditions are there. The first condition is if it remains in state of rest or emotion, there is the summation of all the forces acting on the body must be equal to zero. Either it may be inertia forces, centrifugal forces, okay, frictional forces, okay, all the forces, that is a summation of all the forces acting on the machine member or a mechanism which is to be analyzed must be equal to zero. Then next one is second condition is the summation of all the couples or the moments due to these forces about arbitrary point must be equal to zero. That is, for the body to be in static equilibrium, first condition is sum of all the forces acting on the body must be equal to zero. Second one is couples or the moments acting on the that is raised by these forces must be equal to zero about the arbitrary point. This is called a static equilibrium. Next we can move to next slide. Equilibrium of two force members. Equilibrium of two force members. So what conditions under what conditions the two force member will be in equilibrium, static equilibrium. So now there are some conditions are there. A member under the action of any two forces will be in equilibrium if the forces act along the same line. For example, if we take this as F1 and this as F2, F1, F2 are acting in the same line. Okay, it is shown in dashed line here. Okay, so the points A and B. Okay, it is acting along the line AB. So that is the first condition is the forces, two forces must act along the same line. And the magnitude must be equal, that is same. F1 is equal to F2. And opposite in direction. Okay, so these are the conditions, okay, for the equilibrium of the two force member. So what are the conditions? First condition is the two forces, that is F1 and F2, must be act along the same line. Second one is equal in magnitudes. F1 is equal to F2. And third condition is must be opposite in direction. Okay, F1 and F2 should be opposite in direction. If you satisfy all these conditions, all these three conditions, then body will be in equilibrium under the action of two forces. Next, come to the next slide. Next, equilibrium of two force member. Sorry, this is a three force member. This is three force member. Three force member. What are the conditions for the body which is in equilibrium under the action of three forces? Now, we can observe in the figure there are three forces which are acting. What are those? F1, F2, and F3 are acting on the body. So now, for this body to be in equilibrium under the action of forces F1, F2, and F3 are first condition is the resultant force is zero. That means the resultant produced by all the forces, that is F1, F2, and F3, is equal to zero. And second point is the line of action of all the forces, the line of action of all the forces that is shown in hidden lines. Okay, that is a line of action of all the forces F1, F2, F3 must intersect at a point, common point that is called as a point of concurrency. Point of concurrency, that is O. So all the forces F1, F2, F3 must intersect at a common point, that is called as point of concurrency, that is at O, is shown in figure. Okay, so member acted upon by three forces F1, F2, F3 shown in figure is in equilibrium as the line of action of forces intersect at a point O and the resultant is zero. Resultant is zero means the resultant of all the forces is zero. Okay, how can you find out these forces which are acting on this body? By using a force polygon. Force polygon is drawn to the suitable scale in such a way that the vectors are drawn which are parallel to the forces acting. That is, the direction of vector should be same as the direction of forces acting on the continuum or a body. For example, F3 is in vertical direction like this. So we have drawn F3 by taking some suitable scale. For example, F3 is 100 newtons. So by taking suitable scale, we are going to construct this F3 and the direction is equal to F3, same as that F3. Next, F1, if it is 200, F1 is 200. By taking 200 to the scale, to draw this length, it is this line, a vector length, and equal to direction of F1, in the same direction of F1, you construct F1. And F2 also take the same direction of F2. Okay, and once again you extend till it touches the particular F3 starting point of this F3, that is the first vector of F3. You will get the end point. Okay, so this end point and this starting point will meet at the same point. Okay, so now after constructing this force polygon, we need to measure the vectors and convert it into scale, and finally we are going to get F1, F2, F3 in newtons. So now to find F1, F2, F3, any one of the force we should know, direction of force as well as magnitude we should know. Either it may be F3 uh, 4, that is a magnitude, and direction you should know any one of the force, and remaining we can find out with the help of this static force polygon or a force polygon. Next, come to the next slide. Equilibrium of body acted upon by two forces with a torque. As shown in figure, there are two forces are acting on the link or any mechanism or a body, that is F1 or and F2, and the distance between these, there is a line of action of F1 and F2 will be, that is distance between these two lines of F1 and F2 is h, is a perpendicular distance. Okay, F1 is acting in this direction and F2 is acting in the leftward direction, and F1 is acting in the rightward direction. And the couple produced by F1 and F2 is in counterclockwise direction, because the couple will be produced in this direction, that is in CCW, counterclockwise direction. Therefore, in order to keep this in static equilibrium, in order to keep this link in static equilibrium, we need to apply the couple or a moment in the opposite direction to that the couple produced by the forces F2 and F1. Therefore, what is the direction we need to apply the couple on the link to, this link, to keep this in equilibrium in the clockwise direction. Now, tell me what are the conditions for this equilibrium. First, the condition is the forces must be equal in magnitude, opposite direction, and parallel to each other. So here we can observe F1 and F2 must be equal, opposite direction or a sense, and parallel to each other. These are parallel. Okay, this line of actions will not intersect. These two are parallel to each other. Second one is the couple followed by these forces must be equal and opposite to the applied torque and equal in magnitude. That is, the couple formed by these two equal and opposite forces is in the opposite direction of the applied couple and equal in magnitude as shown in figure. Okay, therefore, F1 is we can say F2H or F1H is the torque that should be equal to T, which is applied in the clockwise direction. Now to keep this link in equilibrium. Thank you.